Okay, so we're picking this up at question 17. And this is the section where I do worry that we're going to struggle the most. So FYI, it's a good thing that the computer decided to come back to life right about now. Question 17, what's the probability of choosing a card that is even and striped? Remember, even means you have to be in both categories. And unless I'm mistaken, the only ones that are even and striped are the 2 and the 4. So first thing you got to do is go through, because this is going to apply to this whole section, and count all the cards. There's obviously 12, and 2 of them are even and striped, and that reduces to 1/6. Good. All right, this is where it gets more interesting, and I know there's still a few of you that are struggling with this concept. Today's a great day for you to pipe up, advocate for yourself, and say, no, I need you to explain that again. These or ones are the ones where we have to add, but then we have to turn around and subtract because oftentimes something got counted twice. So when I looked at this test, I said, okay, I'm going to do this one piece at a time. It says odd or shaded. So the first thing I'm going to do, and this is what you would probably do as a courtesy on your test, is you would write down, okay, for odd, I'm going to count them up, and there are exactly 6, right? The 1, 3, 5, 7, 9, and 11 are all odd cards. And then I'm going to write down the other, which is shaded. And the shaded, there are 3. They're the ones in the bottom right-hand corner. The 9, the 11, and the 12 are shaded cards, so that's 3, right? Now, at this point in time, I would just add them together, right? And I would be done. And I would say like, oh, I'm going to add those together, and I'm going to put 9 over the total number of cards, and I would be wrong. And this, again, is the one thing to me that feels like it might still be a little bit of a loose end for us. Why can I not leave this as my answer? Because I double counted a couple of cards. So let's think about this. And if you think about the odd cards, look at the 9 and look at the 11. Really seriously look at them and not at the TV right now. Do you see that they got counted as odds? Do you see also, though, that they got counted as shaded? Therefore, because there are 2 of them in the overlap set, then we have to take the 6 and the 3, yes, and add them together, but we have to subtract 2 because those 2 cannot be in both groups. And 6 plus 3 is 9, and 9 minus 2 is 7/12 is the answer for that. And I don't think is ever hard for people. It's or. Ors are the poopers. All right, let's head on to question 19. 7/12 is it, yeah. Oh, I changed colors. The probability of choosing a card that is both shaded and striped is 0. There are no cards for which you could say, oh, you're like, shade diped or striped it or whatever. Like there is no overlap there. So 0, it's impossible. Question 20 says, what's the probability of choosing a card that is even or striped? Again, we have to go through the same process again. So how many evens are there? 6. How many striped are there? 4. How many are both? So we have to do the math again. We do 6 plus 4, but then we have to take away the 2. That's 10 minus 2 is 8 out of 12, which reduces to 2 out of 3. Final answer. All right. Question 21 asks us, what's the probability of choosing a card that is a factor of 8 and a factor of 20? So if you want the best explanation possible here, I'll give it a go. I need to find something that's in an overlap of 2 sets. So first off, the factors of 8 are 1, 2, 4, and 8. You guys okay back there? 2/3. Yeah. Sorry about that. Yeah, just tell me to slow down if I get to going. It was 8 out of... Sure, no problem. Yeah. So this is where we start talking or. This is exactly where I would expect that you would get lost. Did you count 6 odd cards?
Sorry?
Do you have 6 odd cards in your... Do you agree? Okay. And do you agree that there are 3 shaded cards?
Yeah, I got that. I wrote it.
Oh, lost doesn't mean you don't get it. You got behind. Okay, so you understand the concept? Rad. All right. Can I head down to 21 again? Okay, so the factors of 8 are up there written in red on the board, and the factors of 20 are 1, 2, 4, 5, 10, and 20. So listen, the bottom line is to be a factor of 8 and a factor of 20 means that you have to be in both places at the same time. And I believe that 1 is in both lists. I believe that 2 is in both lists, and I believe that 4 is on both lists, and that's all. And those are all cards in the chart. So I would just say the answer quite simply is 3 out of 12, which, yes, good job, reduces to 1. Last card question is 22, and that's the probability of choosing a card that is a multiple of 3 or white. So as far as the multiples of 3, those should be 3, 6, 9, and 12. And how many multiples of 3 are there? There's infinitely many, right? Like I could keep going, but I would stop here because, well, duh, the chart stops at 12. Like there's only 12 cards. So, and then the factors of 20 are, again, 1, 2, 4, 5, 10, and 20, but I'm going to leave 20 out because it doesn't really matter. But
What is the factor in 20?
I knew that. It's just testing you guys. How many white cards are there? No. Yeah, there are 5. Yeah, that's totally my bad. And the white cards are, here, let me make this more clear. In case anyone actually goes back and watches this broken video, then this will make more sense. The white cards are 3, 6, 7, 8, and 10. Very good. I did it a little different way on my paper, but this would make way more sense to somebody. So now again, I'm just looking for the OR here. So how many are on this list here? 4, right? There are 4 multiples of 3. How many white cards are there? 5. But we have to subtract it by 2 because it's an OR problem, and the 3 and the 6 are on both lists. Like the 3s are like, hey, you can count me as a multiple of 3, or you can count me as a white card, but you can't count me twice. So that's why for the 3 and the 6, we take out 2. And so we do 4 plus 5, which is 9, and then 9 minus 2, which is 7. So final.
Change my 5s.
It
Right, my 5.
was a long time ago, huh?
Yeah.
Yeah. Any questions on those? Those are tough because some of us struggle with that section. So. Right. That's why I kind of thought the quiz should be Thursday, because sections like that. These ones I think should be more pleasant, but I've been wrong many times before. So for question number 23, we just want the probability if you roll 2 dice that they'll both show 5. The bottom line is if I'm going to roll 2 dice, I just need the probability of each one. So the probability of the first one showing 5 is 1 out of 6. The probability of the second one showing 5 is 1 out of 6. You multiply those together, you get 1 out of 36. Remember, these are what we call independent events. The second die doesn't give a crap what the first die did. It doesn't affect it, right? Like pulling marbles out, those are dependent events because the marble that you pull out affects the subsequent problems, but not here. All right, question 24 wants to know that we're going to roll 5 dice. So the first thing I'm going to do is just put 5 fractions here. And you could use exponents if you wanted to. And then it just says, I want them all to show factors of 9. And again, my work is just kind of saying, okay, here are the factors of 9 on a die. 1 and 3. Remember, 6 isn't a factor of 9 because it doesn't go into it. And 9 is a factor of 9, but it can't count because it's not on a die. So there are 2 of these. So every fraction in this train is going to be 2 out of 6. So I just reduce it and I put 1/3, 1/3, 1/3, 1/3, 1/3, and that comes out to 1 out of 243. So it means if you sat and rolled a die 5 times, and you just, if that was like an activity, you said, okay, I'm going to roll 5 times and keep track of the scores. 1 time out of every 243 attempts, should you get factor of 9, factor of 9, factor of 9, factor of 9. It's pretty unlikely for that to happen. It's not unlikely for it to happen once or twice, but when you start asking the math gods to make things happen in a row. It's like, whoa, slow your roll there. It doesn't happen. Question 25, flip 4 coins. So again, you know what I'm going to do. I'm like a robot. I'm just going to put 4 blank fractions. Four rolls of the die, 4 flips of the coin, whatever. I'm making 4 fractions. And I just want to know what's the probability of them all landing on heads. Well, every single one of them is a half. That's a half. It's a half. Again, everything that happens does not affect what happens after it, right? The coins don't care about what their predecessors did. So that's 1 out of 16. Any questions so far? Should be plowing through this section more than likely. Question 26 asks us about where we're going to roll 3 dice. Ooh. I'm going to pause this real quick. Get through here in a couple of minutes. Question 26 asks us to roll 3 dice, and we just want to know the probability of them all showing odds. You guys must understand that exactly 3 out of 6 numbers on a die are odd, and that reduces to 1/2. And since I want it to happen in 3 times in a row, again, I just stack them. I say the first one is a half, the second time is a half, and the third time is a half. Again, the dice don't get affected by what their predecessors did. A die doesn't have the wherewithal to look at another die and go, oh, you landed on an odd. I better come up even. Doesn't work that way. So this one just comes out to 1 out of 8. The next one, let me get through 27 and maybe 28, and then we'll call it a day, okay? And if I won't get you too close to the bell, I promise. Question 27 says we're going to roll 2 dice. What's the probability that their sum is 10? This is actually, I said this one's tricky. It's not tricky. I don't know what I was thinking. To have a sum of 10. To get a sum of 10 is actually a very limited thing. Like you can't get a 3 on the first die because then you'd need a 7, and that's not possible. So you're locked into 4, 6, 5, 5, or 6, 4. Those are the only 2 dice outcomes that make 10. And since you're rolling the die, this might be the only part that's tricky. Since you're rolling the die twice, there are 36 things that can happen. Do you understand that? 6 times 6 is 36. And there are 3 combinations. Here's combination 1, 2, 3. So it's 3 out of 36, which reduces to 1 out of 12. It does 1/12. Yep. I don't want to. Let me get started on question 28. But again, I will promise I will be the clock watcher, and I will not force you to pack up fast or be late. So here we go. For question number 28, the first thing I have to get out of the way is this. We're rolling a die 3 times. Do you guys know how many things can happen if you roll 3 dice? Or do you know how to figure it out? How many things can happen when I roll the first die? How many things can happen when I roll the second die? How many things can happen when I roll the third die? And 6 times 6 times 6 equals 216. So that might be a little above and beyond maybe what we're used to, but that's really the critical component to this. And then tomorrow when we start class, we're going to go through, remind me that we're on question 28, and we're going to go through and look at all the different ways that the dice could add up to exactly 6. And then we'll count them up and put them on top. So tomorrow we will finish up with 29 through 48. Then Thursday we'll take ourselves a little bit of a test.
Yep.
And I'll be gone.